Hi there, grade 9. I'm going to discuss kite, but before I begin with my lecture, I'd like you to click the subscribe button for you to get notified whenever I upload new lecture video. Now, a kite is a quadrilateral whose four sides can be grouped into two pairs of equal length sides that are adjacent to each other. Its diagonals are perpendicular. In contrast, class, a parallelogram also has two pairs of equal length sides, but they are opposite to each other instead of being adjacent. I'm going to discuss the proofs on the properties of kite, such as in a kite, the perpendicular bisector of at least one is the other diagonal. So when we say perpendicular lines intersect at a right angle. And when we say bisector, for instance, a line bisector divides a line into two equal parts. Okay, so we have the area of a kite is half the product of its diagonal. So considering kite, K-I-T-E here, the one pair of congruent sides are KE and PE. Another pair is KI and PI. So as what I was saying, in contrast to a parallelogram, for example, a rectangle has also two pairs of congruent sides, but they are opposite each other, like this to this and this to this. In relation to kite, K-I-T-E, so the area will be one half the product on the length of its diagonal. So we have one half of EI and KT. So let's work on the proof of each property here. In a kite, the perpendicular bisector of at least one is the other diagonal. Okay? So given kite ABCD here, we're going to prove that really DB bisects AC. And we're going to complete the proof below. So first is kite ABCD. So this is given. So we have to write the word given here. Now, line segment AB is congruent to line segment BC. This should be BC. Okay, so AB is congruent to BC as well as AD to CD. So take note that a kite has two distinct sets of congruent adjacent sides. Now, BD is congruent to BD and BE is congruent to itself BE. And a line segment is congruent to itself, and this is about reflexive property. Now, we can say that triangle BAD, this one, BAD, is congruent to triangle BCD. And this is about side, 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 triangle congruence. In the previous statements class, we were able to prove three pairs of congruent sides. And these three pairs of congruent sides belongs to two congruent triangles. Now, under the side, side, side triangle congruence, if three sides of corresponding parts of congruent triangles are congruent, or three pairs of corresponding sides to be specific, under the SSS triangle congruence are congruent, then we can conclude that the two triangles are congruent. So where are the three pairs of congruent sides? We have AB and BC, one, and then we have AD and CD, two, and then the last pair is BD. Now, AB corresponds to BC, while AD corresponds to CD, and of course, BD corresponds to BD. So, that there are three corresponding parts between the two triangles are congruent. So, we can conclude that the two triangles are congruent under side, side, side triangle congruence. Now, angle ABD is congruent to angle CBD. So the two here are congruent. And angle ABE corresponds to CBE. Since the two triangles here are congruent, of course, the other corresponding parts must be congruent. So we can say here that corresponding parts of congruent triangles are congruent. Now, triangle BAE is congruent to triangle BCE. So, we're referring to the smaller triangles here. So, this is BAE and BCE. Now, AB again corresponds to BC. Okay, and we were able to prove that the two are congruent, as well as angle ABE corresponds to angle BCE, and they are congruent also. And then another is BE is congruent to BE. So we have side, angle, side, triangle congruence for number 6 statement. Now, line segment AE is congruent to CE. This one. Okay. AE belongs to triangle BAE, while CE belongs to triangle BCE. So we were able to prove that the two triangles are congruent. So the other corresponding parts must be congruent. So line segment AE must be congruent to line segment CE. And this is about corresponding parts of congruent triangles are congruent. Now, DB bisects AC. Since the two sides are equal and AE plus CE equals AC, so really we can say that DB bisects AC. And this is about a segment a segment bisector forms two congruent segments. Okay, so next, the area of a kite is half the product of its diagonals. So given here, kite ABCD with diagonals CA and BD, and they intersect at point E. Now we're going to prove really that the area of kite ABCD equals 1/2 of BD and AC, which are the product of the diagonals. So we're going to complete the proof again. So first statement, kite ABCD with diagonal CA and BD that intersect at E, and this is given. Okay. Um, line segment AC is perpendicular to line segment BD. So in the definition of kite, it was stated that diagonals of a kite are perpendicular. Now, area of kite ABCD, this one, equals triangle BCD, BCD, okay, this one, and triangle BAD. And this is about area addition postulate, meaning this kite is divided into two triangles such that the sum on the area of each triangle must be equal to the original kite, area of the kite. And this is about area addition postulate. Okay, now area of triangle BCD is equal to 1/2 EC BD. Okay, and area of angle BAD is 1/2 AE and BD again. And this is about formula for area of triangles. And again, what's the area of a triangle? This is 1/2 times the base and the height. Okay. Now, area of kite ABCD equals 1/2 BC times EC plus AE. Actually, since in the previous statement, area of kite ABCD is equal to the area of this triangle and this triangle. And we know that the area of this is equal to this one, while the area of this triangle is equal to this one. Okay? So we can combine the two, like 1/2 EC times BD plus 1/2 AE times BD. Okay? Now, with this one, we were able to come up with the fifth statement. Okay? So, we know that this has common factor. And by moving out the common factor, which is 1/2 and BD, and then dividing each term by the common factor, like 1/2 EC BD divided by 1/2 BD, we'll have EC, and then 1/2 AE BD divided by 1/2 BD will be AE. So we got this statement, and this is about factoring. Now, EC plus AE is AC. So again, EC plus AE equals AC. And this is about segment addition postulate. Now, from the previous statement, we will be able to prove that area of kite ABCD equals 1/2 line segment BD times AC. So instead of writing EC plus AE, which is equal to AC, we just write AC here. And this is about substitution. So we substituted EC plus AE to AC. So we got really area of kite ABCD equals 1 half BD times AC. So grade 9, I hope you were able to understand the discussion. See you then